Hello, I'm going to continue talking about some of the topics that may be on your SBAC examination. And so one of the topics that we really want to cover with you are probability. And so I'm going to go through with the basic definition and some of the associated vocabulary in hopes that it triggers some memory of going through this in your prior courses. So the very first thing I would say, the basic probability is the definition of probability. So the probability of an event equals the number of desired outcomes divided by the total number of outcomes. Okay. And so some examples of this would be like if I wanted an even number on a die. Well, there are three numbers that are even on a die, 2, 4, and 6. So I wouldn't put 2, 4, 6 in here. I'd put the number of desired outcomes, which is 3, because of each of the values in the set, out of the total number of outcomes, which would be 6, because it's the numbers 1 through 6. If you're wondering what the word outcome means, so outcome is the result of an event. Okay. Another vocabulary word that often is associated with probability, you may see if you start doing some of your own independent studying, you might see sample space. And that's all possible results or outcomes of an event. Okay. Now, there are actually two probabilities that you kind of need to consider. One is theoretical probability. And this is based on theory and analysis of possible outcomes. And you see this when you start rolling dice or looking at a deck of cards. The probability of getting a 2 on a die is 1 out of 6. But when you're rolling dice, there are occasions when you get 2s repeatedly, which would break the theoretical probability down. And so the other type of probability is experimental. And so experimental probability Okay, the other probability that we have is experimental probability. And that's literally exactly what it sounds like. The analysis of the results of an experiment So as I was talking about before, the theoretical probability is so theoretical probability is like, say, rolling a 3 on a die. That's 1 out of 6. Because there's 1 3 out of the 6 numbers. But the experimental probability may show up that the probability of a 3, and I rolled a 3 6 times, out of 18, which would be 6/18, which is 1/3. And so these numbers don't always match up. Again, experimental is me actually performing the act. Theoretical is sort of the abstract theory and analysis of those. Okay? To help us with theoretical probabilities, we oftentimes have to understand very common outcomes. So, common outcomes. Flipping a coin. So the coin has a head or a tail. So there are two outcomes. Rolling a fair die. So you have 1, 2, 3, 4, 5, and 6 on a fair die, so there are 6 outcomes. Spinners are a very common probability. So you have a little spinner, it might go through 3 sections, could be 4 sections, could be 6 sections, just depends. They could have 1 color, 4 colors, etc. So, but spinners are really common. A deck of cards. Huge thing with a deck of cards. There are 52 cards in a deck. There are 2 colors, red and black, each with 26 cards. There are 4 suits, each with 13 cards. 4 times 13 is 52. 2 times 26 is 52. There are 12 face cards. Jack, Queen, and King. And then here's the kind of outline of all of those. It goes Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. All right. The last one that's pretty common is your alphabet. There are 26 letters, 21 consonants, and 5 vowels. Knowing these will really be helpful as you're working through a variety of problems, but the theoretical probability piece, when they expect you to know these answers and these common outcomes, and you don't. So make sure you definitely understand these, you write them down. Okay, the last thing I want to get into with you are counting techniques. Okay, so counting techniques, what happens is you're expected to be able to count large numbers or large sets of things, and it becomes overly complicated. And so they simplify some of these counting scenarios by having a technique to do it for you. So one thing that you need to understand is what a factorial is. Its symbol is the exclamation point. And it starts at whatever number you're given, it multiplies factors counting down. And so the formula would be n factorial is equal to n times n minus 1 times n minus 2 dot 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 2 times 1. Okay? And so an example of this, we'll just pick a random number. Let's say 8. 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And this is just a shorthand way to express a product. It comes up when we start counting different things. There are certain scenarios where the counting really matters, and it can be summarized mathematically. So arrangements. Basically where order matters. So that's a really key part. If you're reading through a problem and you realize order matters, you're in what we call a permutation. So symbolically, they shorthand it NPR, and here's the formula: n factorial n minus r factorial. Okay. Where does this happen? License plates, letters in a word. How can you arrange them? Because order matters for those things. How does this work? You pick a number. We can go with 8, p, let's just say 3. 8 factorial divided by 8 minus 3 factorial. That's 8, 7, 6, 5, 4, 3, 2, and 1 divided by 5 factorial, 5, 4, 3, 2, and 1. So these all simplify out, and I'm left with 8 times 7 times 6. I like to use this a little bit of a shortcut. This gives me my start number. This is my number of spaces. And so the way I do this problem is I have 3 spaces. I start at 8, 7, and 6. It gives you the same exact thing. It's kind of my shortcut. The other counting technique that we have works for collections, but essentially where order does not matter. It's called a combination. It's got a symbol. It's NCR equals, here's your formula, n factorial r factorial n minus r factorial. And so if we kept it with the same example, you have 8, choose 3, that would be 8 factorial divided by 3 factorial divided by 5 factorial, which is 8, 7, 6, 5, 4, 3, 2, 1. 5, 4, 3, 2, 1 divided by 3 times 2 times 1. Boom. So there's the 3 factorial, there's the 5 factorial. These simplify out. I'm left with 8 times 7 times 6 divided by 3 times 2 times 1. And you can simplify things from there. The cheat or the shortcut I like in this scenario, again, it's the same thing. Start number and number of spaces. What makes this different than the permutation is that I just put the start number underneath there, and now I have 8 times 7 times 6, which looks exactly like what we saw over here, and I just fill in the division sign, and that'll work also. Okay, so there's your counting numbers, counting techniques, sorry. And we'll continue talking about probability and statistics throughout these videos to get you prepared for the SBAC. But this is a quick review. Hopefully it triggered some memories. Thank you for your time.